Hello, today we are doing our second day of Mission 3, looking at probability proportions. So the first question says, you have been saving your Bulldog Way tickets all year. You put all 43 tickets into the bin at once. There are 273 tickets already in there. What's a probability that you will be chosen for a prize? Remember, probability is the part that we want out of the total. So they want the number that you will be chosen. So you put in 43 tickets, but our total is not 273. There were 273 already in there, plus the 43 that you added. We need to find the actual total of all of the tickets. So 3 plus 3 is 6, 7, 8, 9, 10, 11. So there are 316 tickets total. And I happen to know that 43 is a prime number. We can't divide it by 2 or 4 or 7 or anything like that. So that is our probability. So now it says if your friend put in 54, what's the probability that you or your friend wins? So your friend put in 54 that make up this that were already in there. So what's the probability that you or your friend wins? Remember, we're adding these together. So you put in 43 and your friend put in 54. So together you put in, let's add these up, 43 plus 54 gives us 7 and 97 tickets out of a total of 316. The total is still the same. And I'm assuming your friend already put in the 54 tickets. If they hadn't, you would have to add that and get a new total. And this is our probability. Second page, it says how many times would you land on a 1 if you spun the spinner 250 times? Well, there is 1 1 on the spinner out of a total of 6 options. So that's our probability of landing on a 1. But we want to know what happens if we spin it 250 times. So our total, writing a proportion, is out of 250. We need to cross multiply. So 6 times x is 6x. Is that equal to the other cross, 250 times x? Oh, no, 250 times 1 is 250. Now, the opposite of multiplying by 6 is divide by 6. So 250 divided by 6 in my calculator gives me 41.7 if I round it. But we can't spin a spinner 0.7 times, so this would really be 42. Running out of space. We round that up to 42 times. Second question, how many times would you land on an odd number if you spun the spinner 85 times? So how many odd numbers are on here? Well, 1, 3, and 5 are odd numbers. So that's 3 out of 6. And we could simplify that to 1/2. So we're going to use 1/2 for our proportion. So half of the time we get an odd number. Well, out of 85 total times, I just use this to write the proportion over here. So let's cross multiply. 2 times x is 2x. 1 times 85 is 85. And then divide by 2. The opposite of multiply is divide. And we get x equals 42.5. We can't spin a spinner half a time, or 0.5, so we'd round that to 43. Round up because 5 is 5 or higher. Third question like this. It says, how many times would you land on a prime number if you spun the spinner 120 times? When we're setting up a proportion, we know 120 is going to go here. We would need to figure out how many times out of 120. Well, prime numbers, only divisible by 1 and itself. 1, we don't really consider it prime nor composite, so we don't really include that. So we really have 2 is prime, because we can divide it by 1 and by 2. 5 is prime, we can divide it by 5 and 1. 3 is prime, we can divide it by 1 and 3. 6 is composite because we can divide it by more than just 1 and 6. Same with 4. So this one actually turns out to be the same as the one up here. 3 numbers out of 6, but we can simplify that to 1/2, just like we did up there. Except we're spinning our spinner 120 times, so if we cross multiply, 120 times 1, and divide by 2. Half of 120 is 60. So 60 times we should land on a prime number. Let's flip over to the back side. Tomorrow we're going to do an experiment very similar to this. You'll have 3 choices, but this is similar to one of them. And we're going to answer questions on this slide and slide 4 about this problem. It says, what's the theoretical probability of pulling a 2? Now, little information here. These 5 numbers were put, in a cup. So each of those numbers was put in the cup. What's the theoretical probability? In theory, how many times should we pull out a 2? Well, there's only 1 2 out of 5 choices. So not 2 out of 5, there's 1 2 out of 5. And then what's the theoretical probability of pulling a 1 or a 4? Well, that's 2 numbers, so it'd be 2 out of 5. So, in class we're going to do an experiment, and we're going to draw paper out of a cup. We're going to do it, let's say, 15 times. And in class, we will actually pull out our numbers out of a cup. Just for the sake of time, I'm going to make up some data. So, I'm going to say that we pull out a 1 twice, a 2 4 times, a 3 once, a 4 5 times, and then a 5 3 times. I think that adds up to 15. 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Yep. So total we have 2 number 1s. We got a 2 4 times, 1 time, 5 times, and 3 times. So now we're calculating our experimental probability. Based on this experiment, what's our probability as a fraction, decimal, and percent? So we know our total is 15, so this was 2 out of 15. We can't simplify that, but we can convert it to a decimal. 2 divided by 15 is 0.13. I'm just going to round to 2 decimals. And then multiply by 100, we get, I'm thinking in my head, multiply by 100, we get 13%. So from here to here, we're plugging in our calculator and dividing. And then from here to here, we're multiplying by 100 to get to the percent. So next we had 4 out of 15. 4 divided by 15 is 0.27. I'm just going to round to the nearest hundredth, or 2 decimals. And multiply by 100, we get 27%. Next one, we have only 1. We only drew a 3 one time out of 15. 1 divided by 15 is 0.07 if I just round it, which is 7%. Then we got a 4, 5 out of 15 times. We could actually simplify that by dividing by 5 to get 1/3, which is 0.33 or 33%. And then our last one, we have 3 divided by 15, which we can simplify as well. We could divide by 3 to give us 1/5, or 0.2 exactly, which is 20%. So in theory, we should have pulled each number 1 out of 5 times, but we pulled 15, so it would be like 3 out of 15, which the only one that matches theoretical to experimental was our number 5s. We should have pulled each one 3 times to have equal outcomes. But let's answer some questions about our experiment. Key word in all of these is experiment, experiment, experiment. We don't care about what should happen in the perfect world, but what happened based on our experiment. So if you're using the experimental data that we have in class, you will get different answers that I am writing right now. So it says, use the data from your table to answer the following questions. What was the experimental probability of you pulling a 2? Well, 2 was 4 out of 15. You're just copying your answer right now. Can't simplify that. What's the experimental probability of you pulling a 1 or a 4? Same questions up here. We should have gotten 1 out of 5 times for a 2, but we got it 4, so we got more times. They're asking the same thing, pulling a 1 or a 4. Oops, right there. Was a total of 2 and 5 is 7 times. So 7 out of 15. In theory, we should have gotten 2 out of 5. We could compare our percents if we wanted to. What was the experimental probability of you pulling a number less than 3? So not including 3, less than 3 was the 2 and the 1. So 4 plus 2 is 6 out of 15. And we can simplify that because these are both divisible by 3. And we get 2 out of 5. Question 6. What's the experimental probability of you pulling a number greater than 4? Well, the only number greater than 4 is 5. So we have 3 of those based on our experimental probability. 3 out of 15, which we can simplify to 1/5. Then number 7, this is a 2-part question. Use your experimental probability to predict what would happen if you pulled a paper out 100 times. So what would the experimental probability be for pulling a 2? Well, based on our experiment, we got a 2 4 times out of 15. They want to know how many should we get if we pull it out 100 times. So we're going to cross multiply. 15 times x is 15x. 4 times 100 is 400. So all we need to do is divide by 15. Those eliminate, and we get x equals whatever 400 divided by 15 is. And we get 26.6, which I would round, because we can't pull a number out of a hat 0.6 times. Round that to 27 times. Last question. What would the experimental probability be for pulling out a 5? Well, 5s, there were 3 of those out of 15. They want to know how many should we pull if we get out of 100. Now, if you cross multiply like this, you will get a correct answer, but we simplified this up here. It's really 1/5. If you cross multiply, you will still get the same answer, like I said. You're just working with bigger numbers. 5 times x is 5x. 1 times 100 is 100. And then the opposite of multiplying is divide. So we get x equals 20. So 20 times we should pull out a 5 from the cup of numbers. All right, your homework is mission 3B. You are looking at the spinner for the the whole front page. It's looking at the spinner, and the back side is looking at selling t-shirts. So you need to read the information up